So in this practice, a 2 kilogram block is set into motion up an inclined plane with the initial speed of the 5 meters per second. The block stops after traveling 2 meters along the planes. So this situation, I would like to start drawing. This is slope is theta is 30 degrees. And originally this block start moving with a 5 meters per second. So you could say that this is V. Then this object start climbing up, moving up. And then after the 2 meters, it becomes B equals 0. Then this length is 2 meters. This is situation. L is 2 meters. Then we'd like to find out the first question. Determine the change of the block of the kinetic energy. First one. Delta K. End stage is 0. Minus 1 over 2 m v sub 0 squares. Mass of the block is given by 2 kilograms. Mass of the block is 2 kilograms. Then you can substitute all the informations. It becomes minus 25 joule. The next question is determine the change of the potential energy. So potential energy is increasing by this amount. So this is 30 degrees. Change of the height is 1 meters. Because this part is L sine theta. This is 1 meters. So this becomes mg times L sine theta. You can substitute. It becomes 19.6 joule. This is the answer to the second question. And the third question. Determine the friction force on the block. Question number 3. K sub initial position K sub 0 plus U sub 0 plus work by the non-conservative force friction equal kinetic energy at the highest point and the potential energy at the highest point. We use these equations. Energy conservation. So frictional work done by frictions can be calculated. Delta K plus delta U. Then we have already discovered this gonna be minus 25 joule. This is 19.6 joule. So it becomes minus 5.4 joule. Then once you have a work done by frictions, frictional force is F, can be obtained minus F times L is the work done by frictions. So F is given by minus W friction over L. And this you can substitute here. L is 2 meters. Then it becomes 2.7 newtons. This is the frictional force. You can discover. So answer to the third question. And the fourth question, determine the coefficient of the kinetic frictions. So question number 4. Object. We'd like to draw the free body diagram. Gravities and the normal force. We can write Then gravity is decomposed in the directions of the normal force and the directions parallel to the slope. So this is 30 degrees. Then this becomes mg cosine theta. So this is square root 3 over 2 mg. Then frictional force. This frictional force is given by F equal mu times N. So to find the coefficient of the kinetic frictions, you can find F over N. F over square root 3 over 2 mg. And then you can substitute F here. M is 2 kilogram. G is a 9.8 meter per square second. Then you can calculate. It becomes 0.16. This is the coefficient of the frictions. Okay, so this is the answer to the fourth question.